Live from Harbor Station, it's the Vector Spaceman Show. Now here's your host, Vector Spaceman.
Hello, Space Cadets. It's your old pal, Vector Spaceman. Yes, indeed, back at it again once more. Coming to you live, straight from Harbor Station and broadcasting on all frequencies to our beautiful planet Earth. Let's zoom out here. Zoom, 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 zoom. Everything's working this time. Fantastic. No hiccups. So professional. Today's Tuesday, February 6th, 2024. Welcome, Space Cadets. Welcome back to the program. And hey, if it's your first time tuning in tonight, welcome aboard. I'm Vector Spaceman, and this is, of course, the Vector Spaceman Show, the longest-running Vector Spaceman show on digital streaming platforms. It's our first broadcast of February. We've got some cool stuff in store for tonight with a little programming project and some holiday-themed content headed our way next week as we get closer and closer to Valentine's Day. Isn't it lovely? You'll want to tune in to see what we're cooking up. The secret ingredient is, of course, love and Spaceman. If you missed the last show, we welcome back our righteous regulars, Dragon Durant, Regal Mikado, and Zenobia Noether, for some Halo Infinite shenanigans marking the launch of the game's latest operation, the Spirit of Fire update. We enjoyed what might have been one of our longest consecutive losing streaks to date, unfortunately, but of course conquered and surmounted our bad luck and bad skills, finally eking out some victories and having a grand old time. Now with the game moving to a frequent update schedule, you can be sure that we're going to see our friends back on the show in short order. So, if you want to stay up to date with all of our broadcasts so that you never ever miss a show, then be sure to follow Vector Spaceman on Twitter, YouTube, and of course, right here on Twitch. Alrighty. Special fun project tonight, you guys. So over the past couple of weeks, I had been talking about leveraging all of the things that we've learned in recent streams as we've been experimenting with Godot and Sprite and Blender and lots of fun tools, that we'd start to put together little mini games that we could occasionally run on the show to kill time or between breaks, that sort of thing. But taking advantage of some Twitch integrated C# code that I had already written in the past to make it a little easier for us. So tonight we're going to try to make that a reality, or at least get started on it. We're going to make our first little mini game in Godot, start to finish, hopefully, or as much as we can get done tonight. Make sure we get input signals from Twitch and get the basic functionality hammered out at least, all live here on stream. Now, I've done some pre-planning, so I got a basic idea of what we'd like to make here tonight. We're going to be making a simple little endless scroller type game where we can control the Spacevan as it rockets through space. Dodging things, picking up stuff. Pretty straightforward, nothing complex. But I keep thinking about how great it would be to expand some more mini-games and maybe incorporate some of our regular guests and co-hosts into their own little games, their own little themed games. So if you guys can think of any fun concepts while we're working here tonight, and after we start to examine what sort of functionality that we can elicit from Twitch, then you let me know, because I'd love to gather some more ideas for future little minigame projects that we can make. Not only does it give me an excuse to keep trying new things in Godot, but of course we get some charming little games out of it. And that's a victory all in itself. So we've got some ground to cover tonight, and I'm going to be explaining the whole process as we go. If you're interested in game development like I am, then maybe you'll learn a thing or two tonight. Or if you're more experienced than Spaceman, well, maybe you can give us some helpful pointers if and when we run into roadblocks. And if you've got no interest in programming or game design whatsoever, maybe you just want a nice relaxing Spaceman to listen to tonight. That's fine too. Feel free to leave us on in the background. Let us know how your week's been going. If you got your own big project, task, or obstacle in your life, I hope you're handling it like a champ. And as always, Spaceman's rooting for you. And now let's dive into our development journey tonight as we load up Godot, and we're going to start a brand new project. So let's put our typing hands on here. Let's see, where are all my assets? Hands. There we go. We'll put on the tablet hands. Those will work. And let's head on over to the big screen. Fantastic. So we've got a brand new Godot project. on the go, on the Godot, as it were. Our Spacevan scroller, completely blank, fresh canvas. First things first, we gotta set up a few things. Actually, first things first, we should get a little background music going here. It's not just the main station music. Let's see. How's about something like this? That'll do. Little jazzy beat. Little bossa nova beat. Alright, so first thing we have to do, we are going to be making a 2D game. So let's start setting up our main scene for that. We're going to make a new scene. Actually, first thing we're going to do, let's make some folders here. We'll make scenes. We'll make a folder for sprites. Make a folder for, what else do we need? Scripts. And we'll make a folder for, like, templates, prefabs, as we'll be spawning some stuff. So let's call that, what do we want to call that? Like in Unity, we'd call them prefabs. Some people might call them templates or blueprints. But here in Godot, I believe they're called packed scenes, so let's just call them packages. Swell. Alright, and within our scenes folder, we're going to make a new scene, and we're going to call it main. And we got to go into our editor here, make sure all our editor settings are set up right, because we want that set to Visual Studio, okay. On our project settings, want our main scene to be our main scene that we just made. Okay. And now, if we go ahead and we run this, we're gonna get a blank screen. Look at that. Okay. We've got a game that technically runs, but does nothing. So let's expand on that, shall we? Now, we're not making everything from scratch tonight because after I was tooling around with what do you call it? A-Sprite the other week, I already threw together some assets that we're going to be doing, or that we're going to be using for this little game that we're working on. So we're going to import those into our sprites folder. Just going to do that off screen here. Let me just copy those in. Spacevan. You can see, I'll drag it over here. We've got all sorts of fun stuff to work with. We've got Spacevan, we've got some asteroids, missiles, little planets, little backgrounds, stuff like that. We're just going to copy all those to our root project folder here. So Spacevan, scroller, sprites, paste those in place, and now come back over here. We should see all of our sprites over on the side there, loaded in. Nice. Nice. Alright, I'm gonna make one more folder. We're gonna call this shaders. We are gonna have some shaders at play here. That's gonna be one of the first things that we actually tackle. It's getting our little background scrolling, looking nice. We want to set up the size of our window here. Because the sprites are pretty small, we want it all basically on the same scale. So we are going to go 512 by 256, nice and tiny, not resizable. Stretch the viewport, keep the aspect. And there we go. All right. So there we are. we're going to start by making our little background here. We're going to create a 2D rectangle, which is going to hold our scrolling background. We're going to set the stretch mode on that to tile so that we can drag it out and it will tile because it's been set up to be tileable already infinitely. That's great. Let's change the dimensions here, fill up the whole screen. So now when we run, we've got a starry background. And if we blow that up, make it full screen, oh. There we go. If we blow that up full screen, you'll see you get a nice full screen. Aspect ratio stays the same. Pixel background. But that's kind of boring, just a night sky sort of thing. Let's make it a little more dynamic. This is where we're going to be making our first shader, first pixel shader. Right. Now, thankfully, because I don't love coding shaders in native language, especially in Godot script, Godot does have a visual shader system that we can make use of. So we are going to scroll down our inspector here until we get to the material, our background object. No, we're just going to name this BG background. And we're going to assign it a new shader material. And we need to make a new shader for this, but we don't want to make just a shader. We want to make a visual shader. So I'm actually just going to create a new resource. In our shaders folder, we're going to look for visual shader. There we are. And we're going to call it scroll VS for visual shader. So we might apply this to more than just the background. We can make it universal. All right, we double click on this and this opens up a window for us here. We want to keep our background visible so that we can make sure everything's working the way that it ought to. Here's our output. Now we're going to make some nodes that tells our sprite what to do. So we're going to take a few inputs here. Some inputs. We need input for time, passage of time. We also need an input for our UV. Our UV coordinates, which are the pixel coordinates of our sprite. We're going to be telling it to move ever so slightly to make it look like the screen is panning from side to side and repeating. And that's measured in green and red values on the X and Y axis, irrespective. Whereas time is just the passage of time. It'll continue to tick up, and that lets us apply functions based on an ever-increasing number. So like a sine wave or something like that. Now we also need to declare some parameters, because we want this to be alterable. We need a, what do we need? A float parameter. We're going to call this speed. This is going to be how fast do we want our background to be whizzing by. And the default value for this, we'll set it as 50. Ultimately, this will be a measure of how many pixels per second do we want the background to go whizzing by. Let's create another parameter. This is going to be a vector2 parameter. And we're going to use a vector2, which is an XY coordinate, to give us direction. So, direction in which our background is going to be tiling. Call this direction. We'll give it a default value of x equals 1, y equals 0, which would just mean that our direction is directly to the right. Our x-axis is horizontal, our y-axis is vertical. So 1, 0 in this case means directly to the right. That's pretty much universal. The only thing that sometimes you might get tripped up by is your y-axis up on your screen or is it down on your screen? Because some game engines will handle that differently. Alrighty, let's see here. Time to start linking these together. We need some operators as well, because we need to multiply our time by our speed, by our direction. First of all, let's add a vector operator. Set that to vector 2. We need to multiply speed by direction. And that gives us a velocity. That's great. We are then going to but multiply our vector 2 that we've just composed here, synthesized. We're going to multiply that by time. And vector 2, we want to multiply, I should have said, well, pass this value in here. Now we have time multiplied by speed multiplied by direction. We're going to add all of that to our UV value. So ultimately, as time passes, you're going to be adding on this vector 2 to our existing UV, basically telling it to shift to the right, or whatever our direction is, by a specific speed. Unless I've got time in the wrong place. We're going to see this in action in a second. So we need to create another vector operator. This time we are actually adding UV to that. Now we need to create a texture 2D. This is what we're going to be outputting. We pass the UV that we've just created. This ultimately goes into our output. Hold on. You know what we should have done? Hold on. We never assigned this to our I want this to be a canvas item, not a node 3D. Okay, that's why I was throwing that error at me there. Okay, now we want to pass this through the color value, and something has gone wrong. Something has gone terribly wrong. Unless it's just moving too fast. Let's look at our shader parameters. Let's lower the speed to something like 5. Still not getting anything. All right, which means oh, this fell off. Time fell off for some reason. Our UV fell off. There we go. Okay, now we've got it going. And as you can see, our background is whizzing by. We lower speed to 1. Oh, there we go. Nice and easy. So this is not moving at a rate of pixels per second. This is actually moving at a rate of entire tiles per second. Which we can still work with, but that was not the intended design. So is that because we misarranged our inputs here? I wonder. I'll have to go back and examine that at some point. But at least we've got it functioning. So I'm thinking we're actually going to set this to a speed of 2 or 0.3, and you can see I accidentally set it to a negative value there. It goes the other way. Another thing we can do, we can adjust the Y value. So, for example, if we wanted it to be adjusted on the Y-axis as well, we can put a number in there, and look, now we're scrolling diagonally. So it's that easy. I'm pretty pleased with the visual shader, node graph sort of system that they got going here. Makes it a lot easier than trying to learn whatever shader language they're using here in Godot. Plus, you can arrange it all nice and... You get fixated on that stuff like I do. Oh, but another nice little feature they have here is they can automatically generate shader code for you. And this is a little sloppy. Like, you wouldn't use like this jargon as variables in your own code. And it seems a little redundant, like you could definitely refactor this to be a lot more concise. But it is something that you can copy out and conceivably import into other shader languages as well, as long as you know what everything stands for. Vector 2, obviously a vector 2. Floats are floats, that makes sense. Okay, but we've got a nice scrolling background here. Step 1, done. Now let's put our little Spacevan on, shall we? Point 2 seems okay. Alright, now we're going to give ourselves a little player. And for this we're going to need some sort of rigid body. We're going to use a character body. Specialized for characters moved by script, which is exactly what we're getting. We're going to call this Spacevan. And because it's an extension of a rigid body, it needs a collision model, so let's give it collision shape 2D, which we'll define in a second. And let's give it a sprite, so that we can show the shape, Spacevan. Let's assign that texture. Bam, now we got a Spacevan on screen. Let's move him down here. Whoops. Make sure we're selecting parent node. Move him down here. There's our Spacevan. And he's got a little rocket coming out the back. Now that's not animated. We could have done something like an animated sprite 2D, but I just hadn't made additional frames for the Spacevan. So there's something else that we're going to do to give it a little extra life so it doesn't look so static. But first we're going to finish setting up our player here. So we need to give it a collision shape so that it can collide with other in-game objects, like collectibles or obstacles, stuff like that. Let's give it a new rectangular shape. Let's just define the bounds of our Spacevan. And that's good enough for us for the purposes of this first little foray into our game. Now we could technically, like, let's add another one here. We could, if we were really feeling it, get a little more specific. With our collision objects, we could create something like, let's see, I'm sure there was one that lets you click and draw. Basically, I know that there is one where you can set the boundaries of your model, basically almost like a 3D model, by triangles, effectively. Or what you can also do is you can like stack up collision shapes. So you could add circles for the feet for the tires. And you could duplicate that and bring over another one here. Then also add on collision shapes for the hull, for the main body. And maybe you'd bring it to like here or something. Then you add another one kind of at an angle there, because you can rotate these as well, and another one for the front if you really wanted to be, you know, precise about collisions. For the purposes of our little game tonight, we're not going to worry about that too much, so I'm just going to make do with our one little box collision model. And let me take a little drink here. Alright, next thing we're going to do. Got our Spacevan. We need to do something so that it can be controlled. So it can move around the screen. That's pretty simple. Oh, what I wanted to do before that, I wanted to mess with the rear of our Spacevan here so that it produces a little effect. We're going to add BBU particle 2D. It's just going to be a little particle emitter. We are going to attach this, parent this to our sprite so that it moves wherever the sprite moves. We need to give it a new particle process material. We do that, and oh look, now we're dripping particles. Fantastic. Let's move this to the back of the Spacevan. Our little exhaust here. Now right now it's being affected by gravity and all sorts of stuff, because at its core Godot is a physics engine. We just need to change some settings here. Let's see, velocity. Gravity, so we're going to say no gravity, thank you very much. We're going to say initial velocity. You can see our particles are shooting out here at a direction directly to the right. We actually want this to go directly to the back. Let's say 50-50 for right now. And we want to give this its own unique texture. We're going to assign this little plasma ring that we've got here and off the back. So look at that. Now we're shooting out little type plasma rings, which is fun. We are going to flatten out the spread of our distribution here. Right now we've got a spread. This spread value is at 45 degrees. It's saying, okay, either direction, we can have a little variance in where these get shot out to. If we brought that down to 0, they're all just going straight to the back. But we like a little random distribution. Just gonna flatten out that distribution a little bit. 0.5 or 0.6. Go. That's fun. And what else are we going to do? We are going to accelerations, linear acceleration. Want scale. Here we go. We're going to make a scale curve. All we're saying with this is, as it gets further away from our emitter, our rings are gonna get a little smaller. Beep, 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 beep. That's fun. Right where we at. That looks good. Okay. For that spread. better. We can also change the initial velocity, give it a curve, can't we? Killer velocity, velocity curve. Make it sort of speed up as it gets further. What it should do. Let's see if that functions. No, I don't think that's right. It's not much for us. It's a function that I'm thinking of. The one thing I know we have to make sure that we set is Z-lock, because if we go ahead and we rotate our Spacevan right now, we'll see that the little emitters, our little particles, aren't actually rotating with the van, and that's something that we'd like to make sure that they do. So, let's see here. Let's find that. Transform, maybe? Rotation, skew, no. It must be under. So. We can also set other things, like the amount of particles that we given time. We could set this to something like 24. Suddenly we've got this big long stream of particles there. I actually think 8 works well for us. It's not overwhelming. So I think we'll keep it at that. Ability, yada yada. Alright, so back here. There it is, disable Z. We're going to turn that off. Now, when we rotate our Spacevan, our particles rotate with it as well. Make it look like it's really being emitted out of the back of that little thruster there, that little booster. Swell. Now, we would also like to give this some pre-processing. Where is the option for that? Let's see. Pre-process. And what pre-processing does is, for example, if we launch the game right now, we'll see our particles start to emit as soon as we start the game. If we add a pre-process value, that means that the game will basically simulate a certain number of seconds of emission before the game actually gets started. So we'll load into the game and those will already be shooting out the back of it, as if, you know, the van's been in motion the whole time. So we'll just add 1 second of pre-processing time. Now when we load in, oh, look at that. Spacevan's puttering along, beep, 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 doing its thing. Fantastic. That'll sure. It's good. All right, we've got a Spacevan motoring along. Look at that. Looks almost like it makes for a nice little animation there. It's fun. The background, we can add some like scrolling planets and stuff too. We'll probably get around to that. But what I want to do right now is add some motion capability to the Spacevan so it can move up and down across these lanes. And we're also going to get that hooked into our Twitch signals. So first thing we're going to do, we're going to make a new script for our Spacevan. Attach a script. It's going to be a C# script. We are going to call it Spacevan. Yeah, so it already sets that up for us, and we're going to put that in our scripts folder. I don't want basic move. That should be easy. All right, we're going to create this. That's going to load up Visual Studio for us. As you can see, loaded on my other monitor here. Bring it over. Gives us a bunch of default code, which we do not need. We're going to delete a bunch of this. We just want physics process override, and we also want override void ready? Yeah, ready. And these are just root methods that get called when the character body 2D code instantiates. In the case of ready, and anytime that our physics process is called. So a number of times per second the game is set up to call physics process, as opposed to just regular process, which is called every frame that it's rendered. But that's variable across different people's systems. We just like to use the physics process for important stuff like movement and position and what have you. All right. Let's start working on inputs here. So we're going to create some basic up-down functionality. Spacevan is going to need to have some information stored in it that tells us what lane it's in. So we're going to have a top, middle, and bottom lane. As you can see here, some stuff up here, some stuff down here, some stuff over here. We're going to have off-screen spawners hitting us with stuff to collect, stuff to avoid, you know, infinite scroller type game. And we're going to be able to control the up and the down through Twitch redeems. But just to make sure that we got the basic methodology working, let's create public enum. We'll call this, what are we going to call this? Lane. And have 3 different values for now: top, middle, bottom. Well, now the Spacevan is going to have a public lane value. Call it van lane. Hey MB, thank you so much for the hydrate redeem. Let's all hydrate, you guys. Delish, and a stretch. Oh my goodness. Thank you so much. Big stretches, you guys. Big stretches all around. I'll even throw in a crack just for free. That's good stuff. How are you doing tonight, Ambi? Thanks for tuning in. We're doing a little Godot playing around with stuff tonight. Got a little Spacevan. He's flying through space. We're just about to give him some functionality of movement so that we can control it through Twitch redeems. Kind of like the redeems that you just did. See how that works in a second. But right now we just want to be able to set lanes and move our van between them. So we're just going to make some false inputs that we can control on our side so that we can change lanes. Alright, so we've got a van lane. When we instantiate the van, we're going to say that this van lane is equal to lane.middle. We always want it to spawn in the middle lane. Now we're going to need to give our lanes values, Y values, so that we know where to move our van to. So let's go back into Godot here and let's our transform inspector. So how about something like, let's see. Yeah, that works, I guess. model. Nice. How are you doing tonight, Ambi? What were you up to tonight? Doing something fun? Doing something meaningful, I hope? Okay, so we know our middle lane is going to be equal to 120, top is going to be equal to 40, our bottom is going to be equal to 200. And these are integers which are just going to be placeholders for our y value of the lane that we want to move to or from. That's what an enum is good for, an enumerator. It's basically an easy way to define something numbers and give them little variable names. The alternative would be to do something like create a whole class and we call it like van lane. In van lane we would have public static or read only, even read only int top equals 40. That would function basically the same way. And we could, in our Spacevan, we could say store a public van lane, and we'd instantiate it. We would say this dot van lane, or sorry, this dot lane is equal to van lane dot top. Why is it? Static. Ah, there we go. Can't implicitly convert van. Because right, that should be cast as answer. Okay. But yeah, basically gives us the same function without creating a whole new class. Just relaxing after a hard-ish day, but that still means more work because I'm insane. Well, that's what you get for being a go-getter. For trying hard and doing your best, which I'm sure you are. Maybe you can help us test out this little game as we get it going here tonight. Or if not, enjoy a little spacey jazz, a little Spaceman, talking in your ear as you try to relax on a Tuesday evening in February. Alright, so, after explaining all that, we're going to set our capitalized van lane. Our van lane is going to equal van lane dot middle. Now we need to allow us to move between. So every physics process, we are going to get ourselves some input. Going to create a private void. We're going to call it get input. I should call it get false input since it's basically going to be a stand-in for our Twitch redeem actions in a little bit here. But for the moment, we can just call it get in. And we're going to cast a couple of if statements here. So we're going to say vector2 input. We're going to create a vector2 called input is equal to vector2.0. Just a 0 value right off the bat. And then we are going to get our inputs. We're going to add that to that 0 value, and then we're going to return that value. So we shouldn't even be calling this a void. We should be calling this a vector2 because that's what it's returning. Hello, PK Ninja. How are you doing? Good evening to you as well. Welcome to a Godot stream. We're making a little Spacevan, and we're about to make it move and do stuff. We're making a move between lanes. We're making a little endless scroller sort of thing. All right, so let's check our inputs. So if input dot, sorry, that in, if capital input dot action is pressed. Yes. Now Fortunately, Godot doesn't have a built-in method for checking when a key has just been pressed. It's got methods for checking when user-defined actions have just been pressed. But that means we just got to set up a little extra something in the editor. We're going to say, has an action just been pressed? We're going to give a string name up. And if it has, then we are going to say input plus equals vector2 dot up. And we're going to duplicate that. We're going to make the same check down plus vector2 dot down. Or we could also say minus equals vector2 dot up. Now, thankfully, and I have figured this out through testing, is that even though Godot's y-axis extends from the corner down, so down is considered to have an increase in how you say, in value for the y-axis. So we go from 0, and further we get down, we get larger numbers. For scripting purposes, Godot does consider vector2.up to be a negative value. So it's already done that conversion for us, which is helpful. I'm doing well just finishing up a color analysis thing for my animation cinematography class. Nice. We love colors. The ones we can see, at least. All right, so we're going to apply those, and then we're going to return input. Now let's give ourselves some exported parameters here. Stuff that we can edit in the inspector. We're going to export private float speed, be the speed of our vehicle, our Spacevan, and we're going to also, what else do we need? Don't know if we need anything right now. Check this. Every physics frame, we're going to say this dot position, the transform position of our Spacevan, going to be altered by the value of get input multiplied by our speed multiplied by our delta value, which is the time between now and the last frame that was rendered. Passed as a float because a double is twice as long as we have to pare it down a bit. All right, and with that, we should be able to move up and down. As long as we go into the project, set our project settings, go to the input map, we're going to add a new action. Up. Assign that to up key. Then we're going to do the same with down. That. Give it a key. Down key on the keyboard. Very good. Okay, run it. Now, oh shoot. You know what? That's not going to be very good for us because we set it for to only run when the what do you call it? When the action is pressed. We're going to change that from just pressed to action pressed. And we're not going to use this for very long. We're just demonstrating that it do work. Now, it's not moving. It's not moving because it's not moving, DK. I know why it's not moving. because we haven't assigned a speed value. So our speed is considered 0. Ah, Spaceman, you dummy. We should have gave it a default value in the code. Let's change that to 50. Let's go back into the code. Let's give it a default value as well. Back to the editor, and now we can see, bam, look at that. We can move a Spacevan up and down, but we want it to move automatically, so that eventually we can tie it to Twitch inputs. Looking at all of this code is reminding me of the web development class I had to take, also known as the college class that made me cry the most. Make it infinity speed? Well, here, we can jack it up to like 500. Go back to our preview here, and now it goes zoom, zoom, zoom. As fast as we want, really. We can blow it up, make the screen bigger, zoom, zoom. So we can really dodge stuff, zoom, zoom. But it's kind of stiff, isn't it? Like, we've got our little boop, 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 boops coming out the back, and that's fun. But we want it to, like, rotate as we move and what have you. And we want it to move between here, here, and here, because we're going to have 3 different lanes of stuff to collect and dodge. So let's change the simple stuff first. Spaceman. Revenant Novaric, how are you doing? You see what we're doing here? We're making stuff in Godot. We're making little mini games. It's fun. I hope you're having a lovely Tuesday and a lovely February. We're making our Spacevan go fast. Alright, so how to move it between lanes. We have to create a method that will compare our current lane to our inputs, and then change our position. So we're going to change this back to just pressed. We don't want this constantly changing. Looks cool, I never messed around with Godot. Well, hey, you can learn along with us. We're no expert. We're just using the little programming experience that we do have to make something fun. Let's make a new method called change lane. Got a signal before you change lanes, don't forget. And what are we going to do here? We're going to take a input. It's going to be derived from our local get false input. You know what? Go ahead and call it that right now, because it really just is a placeholder for what we're going to be using. So we're going to take an input and we're going to throw some if statements here. So if input is equal to vector2 dot up, we're going to do something else. If input is equal to vector2 dot down, do something else. Otherwise, return basically, or even out, depending if we're rotating the Spacevan. Okay, so if the input is up, then we have to check out our van lane value. So if our input is up, then if this dot van lane is equal to van lane dot middle, then we're going to say this dot van lane is equal to lane dot top. We're just going to move it up a lane, and we're going to say if the lane is equal to the bottom, we're going to move it to the middle. And if it's already the top, then we're not even going to do anything. We can basically copy and paste this down here, except we're going to change this. If it's to the middle, we're going to change it to the bottom. And if it's the top, we're going to change it to the middle. Now during our physics process, we're not going to be changing the position based on our false input anymore. We're going to be calling some other method called van. And we're just going to say if this dot position dot y, our y value, our up and down value, is greater than this dot lane, van lane, cast as an integer. Remember, that's why we use an enumerator, because it allows us to tie integer values or number values to this, how you say, to these labels here. So if our position is greater than the lane that we're supposed to be at, then here's what we're going to do. This dot position, we're going to change our position, is equal to this dot position dot move toward our new target. It's going to be a new vector2 where we're going to keep our current x value the same, but our y position is going to be our van lane cast as an integer. Okay. And we need the weight, the amount of speed. So that is going to be this dot speed multiplied by our delta value. So we're going to have to pass through our delta value, and of course we're going to cast it at float. So now every physics process we are going to say, move van. We're going to pass through the same delta value that's already inherited by the physics process. All right, we're going to copy and paste this here. We're going to change this around. It's less than this van lane. Then, you know what? We don't even have to do less than greater than, do we? No, we can just say if this position dot y is not equal to this van lane. Okay. Now, let's go try this out again. Make it nice and big so we can all see. So if we press up, nothing happened. Why does nothing happen? I didn't set it up to call correctly. Spaceman. So every frame, first we have to call change lane. And our input is going to be get false input. Calling a method within a method, or using one method as the input for another method, and then we're moving the van. And that should work. Boop, 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 boop. We move up to our top lane position, we move down to our mid lane position, we move down again to our bottom lane position, we press down again, nothing happens because we're already at the bottom. If we press both keys at the same time, nothing really changes. Does a little jitter there. We can actually change between, like as we're partway toward one lane or the other. Is that something that we want? I think so. We shouldn't have to wait to go all the way to one to get to the other. It allows us to sort of correct or have conflicting inputs. I think that's fine. So now that we've got that functionality working, we can actually hook this up to Twitch, and we can let you guys control it. So what are we going to do for that? We are going to dump some stuff that I coded beforehand into our scripts folder. So let me just do that off screen for a second here. Let's see. Sources. Copy you guys. our Spaceman scroller scripts. You go root folder. Okay, and then back in the editor. You can see we've got new scripts here. We've got a Twitch client, we've got event subtypes, and we've got ID info, which I'm not going to open up. And remind me not to open that up on screen because that's actually stuff that we shouldn't be sharing. Otherwise, you could take control of Spaceman's channel, and we don't want that. But the important stuff here is the Twitch client and the event subtypes, because this will allow us to connect Twitch. We just gotta go into our, here we are, Studio, YouTube Studio, Visual Studio. We want to load our Twitch client, and it's going to throw a bunch of errors at us, probably. Yes, because we need to sync these imported libraries with our project. This always happens. Let's just try running it. Failed to build project. Okay, that's good. Let's fix all these errors, and then we should be fine. Okay, we need to... packages, we just need to install... let's see... Newtonsoft, which is a JSON library. Now, technically, Godot has its own JSON parsers and stuff like that, which is great, but I coded this with something else, so I'm just going to keep it with what we're used to. Okay. Okay, and technically, Godot also has WebSocket and HTTP request functionality built into it, which you would expect it to. But once again, we're just going to use the stuff that we've pre-coded, which was originally just designed to work as like a C# console application. But since Godot also accepts C# as a programming scripting language, we can actually use it right within the editor. It's great. Okay, close all this down. We shouldn't have any errors anymore. That's great. So yeah, this is all our pre-built stuff. Close out of that. Now we need to instantiate a Twitch client at runtime. Won't that be fun? Let's do that. First, let's just run. Failed to build project. Okay, I love it, having to do this a number of times, every time. Not too concerned about this because this has happened before. Project just needs to be updated a couple times for whatever reason. Save all this. Actually, close it down. You know what? That might actually make it easier for us if we just close down the project, reload the project. Back to the screen. We're back as well. Okay, let's try running. Okay, we're back to being functional. That's great. Alright, but we're not connected to Twitch right now. I mean, sorry, we're connected to Twitch, but the game isn't connected. Obviously, we're connected to Twitch because we're streaming. You're watching us on the show. But let's do that. Let's connect ourselves. We're going to create a new script. We are going to call this is going to be like our global script. Now, thankfully, Godot lets us instantiate scripts like singletons, but they're not quite like singletons, like global variables. At least not in the way that you would think of singletons as being like a data structure, like a data pattern. But they still call them singletons for some reason, which I find a bit annoying. But I get what they're going for. They mean that we can instantiate scripts as, basically as, like single-use entities. You can only have one of them at a time. And that's great for having global variables or player preferences or stuff like that that's going to be consistent throughout your game. We're going to call ours Game Manager. That's where we're going to put our Twitch client. So yeah, we're just going to inherit from node, create our Game Manager. Let's open up our Game Manager script. Okay, and we're going to say that when the Game Manager loads, Game Manager needs to have a Twitch client. Make a Twitch client, call it client. When this script is instantiated, we're going to say that this client equals new Twitch client. Then we are going to connect that client. Retries. And I can show you guys a little under the hood of what we've written here. So basically, the Twitch client is just a WebSocket client that connects to the Twitch event subserver. When we connect it, we try to get a connection. If it doesn't connect, we retry that a number of times. Anytime a message comes through, that we get a message from the server, we'll try to parse it, get some data from it, some information. We can add listeners, we can remove listeners of different types. That's why we have the event subtype class here. It allows us to subscribe to things like when we get new followers, or when an ad break starts, or the important one for us is channel point redeems, because that's what we're going to be listening to tonight. That's how we're going to be controlling the Spacevan. Alright, so we're going to connect to that at start, at runtime. And that should start a connection for us. And because we've already done editing from the console to a more Godot-friendly format, we're actually printing to the Godot inspector sort of output console when we get messages, when we get errors, stuff like that. So we'll be able to read it right in Godot, which is great, which is very helpful. But in order for that to work, we need to go into our project settings and we need to auto-load. Our game manager. Enable it as a global variable. And that's what tells the game, okay, this is going to be loaded before the game even starts, basically. And this is going to be a script that anything in the scene tree can call and get data from, or call the methods of, as long as it has the correct root address that we reference. So the fact that all of our stuff has to reference the game manager or the quote-unquote singleton like an object is what makes me feel like it's not really a singleton pattern. But it's fine. I get what they're trying to do, and it works. And even though it seems to work better in the Godot script than it does in the C# script, I'm not gonna raise a stink over it. It's just one of them things. All right, so now when we run the game, check this out. Let's read what happens down here. Ooh, a lot of stuff is going on. We've got some action in the chat here, you guys. All right, so what has happened here? We attempt a connection. We establish a connection. We're starting to receive welcome messages. We send a message back. We clear old listeners. We add new listeners. And now we've got a listener established for channel point readings, which is great. Because now anytime that a redeem gets put through the chat, we're going to be able to parse data from it. We're going to be able to read it, get some information, some useful information from it. So if any space cadets are out there and they want to make a little redeem for us, I'm feeling a little thirsty. I could use a little drink, I don't know. Or maybe a stretch or something like that. If anybody feels like putting a little redeem into the chat, start to see some action here. What else are we seeing? We are seeing keep alive messages. So this is basically ping pongs between us and the server, keeping our connection alive. But we've got a little redeem here. Let me scroll down. Here we are. So we missed this one coming through, but it is here. So we have got a event. PK Ninja, BT, that's you, redeemed Hydrate. And it also tells us the ID of the user who redeemed it. In case you didn't know your Twitch user ID, we're all learning things here. How much the redeem cost. I think it tells us when it was redeemed as well. All sorts of useful information. Yeah, created at this time. The thing that we're looking for, the important thing that we're looking for, is the reward ID. So this is the unique ID of the redeem, and we're going to be able to use these to control the Spacevan. All right, so what we're going to do for the purposes of this stream, and then we get all these keep alive messages. These will keep coming through. I'm just going to scroll to the bottom here to keep up with the messages. Yeah, but that's the basic functionality of how we're going to use Twitch to control stuff on the screen. Now I'm going to go into my Twitch dashboard here, and I'm going to enable a couple of new redeems. So, under your redeem panel, you might now see move up and move down as redeems that you can use. And they're very cheap. I made them cheap on purpose because we're going to be testing them out tonight. So for the measly little cost of 1 cadet credit, you can move up and move down the Spacevan. Somebody test that out, make sure it's working for us. We're going to need at least 1 use of each one. You know what? I can do that for my... Oh, PK's on it. Look at that. Boop, moving up. Okay, so that's great. Let's take a look at this. We've got our ID of the move up redeem and the move down redeem. This is great. Let's start with the move up one. We're going to copy this ID here. Copy. Now we're going to go to our Twitch client C# script. All right. Now I'm just going to store these values for a second here. So that's up. And was the down? Let's see. Down, that was the ID for down. Actually, I'm just going to sever the connection here by stopping the game. Otherwise, we're going to keep getting these, hey, are you still there? Are you still alive messages? All right, that is our down ID. Perfect. Thank you for that, PK. That will be very useful for us. All right, now we need to decide right, we're going to modify our change lane. We're just going to make a public method so that it can be accessed from outside by other classes. And you know what? Maybe we don't have to. Maybe we can still make it private. We're going to make it public right now because we're not so worried about security or nothing like that. Alright, we're going to call this change lane Twitch. Because you know what? Maybe we should have multiple ways to influence this so that I can still control it locally and you guys can control it remotely. Change lane Twitch. We are actually going to pass through... what are we going to pass through? Just a string, I guess. String... what do we call it? What does this JSON call it? ID. If ID is equal to a particular value, and we're gonna move the lane up. Else, if ID is equal to another particular value, our down value, then we're gonna move stuff down. Copy this stuff here, here, this, here. Use. Alright, this, we move the lane up our ID. This, move our lane down. Now we need to parse some messages. And these messages from the Twitch server are all JSON format, so thankfully, I've already written a way to extract that data. And I was kind of silly, instead of just casting it as a library or as a dictionary, I cast it as a variable, or as a variant, or as a dynamic variable, technically what it's called. So we can take a look at our WebSocket message method here. So when we get a message, we pass that data, message, serialized. Okay. I think the easiest way to do that. Let's see, what's the easiest? If message type session welcome. For a moment, I thought you meant literal Twitch messages. I was prepared to say something random like I like. Well, we can also listen for like chat messages and stuff like that. And we can make stuff happen in the game or in any sort of minigame in response to, you know, when people say certain words in chat and stuff like that. Like, that's stuff we can do as well. That's not something that our little minigame tonight's going to be designed for, but it's something we can implement in the future. So I've been thinking, like, what are some other minigames that we can make in the future? Continue our little Godot trials, make some fun stuff, elicit some more utility out of Twitch. Lemon meteor every time someone says lemon, just gets spawned lemons. That's not the craziest idea, PK. You might be onto something. Alright, so right now the only thing we're checking for with our message that we're receiving from the Twitch server is to respond in a certain way when the message type is a welcome session message. But we could also add another case here. I'm cooking with the lemons. He's cooking. He's cooking with those lemons. Here's what we're going to say. If the... Let's just read the format here. All right, if the da-da-da-da-da... Okay, that's something we can do. If the message metadata subscription type equals what we're listening for, hey, I was using that up. Dot subscription type equal to this, then we know that it's a redeem. So we can investigate further. If our message.payload dot event dot reward dot id, payload event. And see, this is why we should have just done this as a dictionary, because sometimes we have keywords. Thankfully, we know the trick. We know to go at event, and that overrides it. Dot reward dot, what was it? ID, reward ID. It's equal to when does this move the van down? Okay. You know what? Maybe we should just pass this data. No, because I've got all the deserializing stuff in here. So we'll just make it work in here, and I'll move it around later if we have to. Alright, I think we're going to have to work with signals or something. Yeah, I think so. Here's what we're going to do then. We create a couple of signals, which are ways for us to communicate between classes by emitting those signals. Say public, delegate, void. What do we call this? Switch up event handler. Another one. Switch down event handler. Okay, so when this one comes through, we want to emit signal. It's going to be a signal name. Switch down. Aren't you picking up? Shoot. What did we do? It's the right way to format it. It'll tell me what the error is as soon as we mess around with this. Actually try implementing it. Or up with you. Oh, lady. Okay, so now when those particular messages come through Twitch to us, we're going to emit signals that other classes can pick up on. So we need to in our Spacevan, we're going to reference our game manager. say private game manager, and load. I'm gonna say this game manager equal to get node game manager, and so this is how we reference our, how you say, like singleton-esque, global-esque classes. Path is root, the name of the class. Probably shared data between game Spacevan. It's going to be private Spacevan. You know what? We're going to have to public actually. Change the value of it. And make the Twitch client. Well, after we identify our game manager, we are going to say that this.gamemanager.spacevan is equal to this. So we're going to self-assign our Spacevan to be the player, basically. You know what? We don't even have to go in that far. Say after we assign ourselves as the player, we could say this.gamemanager.twitchclient connect that's trying to Twitch client is a Godot object. What if we tried inheriting 2D or something like that? Oh shoot, that's why. No. That's why it wasn't working, because I was declaring those in the simple Twitch API namespace, not inside of the Twitch client itself. Okay, if we put those signals in there, now that works. Back down to our WebSocket message. Where did you go? Too much code here. Here we are. Okay. Now that should detect. Signal name dot Twitch up. There it is. Signal name, Twitch down. You always overlook something or another. Or at least I always do. Alright, now we just need to connect those signals to our Spacevan. So true, so true. And you know what? We'll let this... Should we let the Spacevan handle that? Hold on. Client dot... We have two different connect methods here. Okay, so it does inherit it, so that's fine. The amount of small details I missed in that web class, it happens, and then you sort of struggle your way through, and then you find some really simple way, figure out what was going on, and you're like, ah, gosh. All right, because I don't think we need to... send arguments as well. Okay. Follow me here then. I'm gonna comment this out for now. I think we can do this all with just one signal. Garsh was the exact word I used. It elicits, right? Make another signal, public. We'll get void. I'm just gonna call this Twitch input. Handler, it's a naming convention. Comment this out now. Pretty sure we don't need it. So we're going to say if the subscription type is equal to this, then we're not going to do any other check. We're just going to emit a signal. Should be Twitch input. We're going to pass an argument. It's just going to be the message payload at event report ID. We're going to cast that as a string. Should be a string. Okay. Now we just need to connect our Spacevan to the Twitch client. We're going to connect, not that connect, this connect. String name signal to a new callable. Right, so we always connect from the perspective of whatever is going to be emitting the signal, basically, is the way I think of it. Signal name dot Twitch doesn't to give us the list, so we're just going to say Twitch input and just by string name. We're going to have to make a new callable. Target is going to be this. The method calling is it? Change lane Twitch. Okay. In Twitch. It's named correctly there. Okay, so we're passing through a string. That's going to be the ID. We're checking the ID. That's telling us whether or not we can move up and down. That's changing the lane value, and we're still calling move van every physics frame. Don't need this manual stuff. So we can change lane, moving the van, so I can still move it, and now you guys should be able to move it as well. All right, moment of truth. Going to run the game. Going to reset our connections. Okay. Retry our connection. Hold on. Connection error again. No worries. These things happen. There we go. All right, we've got a connection. Now I can still move us up and down. The real question is, can you guys move us up and down? So does somebody want to try using a up or down redeem? Oh, there it goes. There it goes. That wasn't me. That was you, PK. Can you move it down? Woo, that's right. And we're moving it down and it moves down. That's great. That's the basis of Twitch integrated games in Godot. Using redeems, using emotes, using chat commands. We can do all sorts of stuff. Now, we should have a reason to move up and down. So the next thing we're going to do is we're going to create some obstacles, some collectibles, that sort of thing. All right, so back to working in Godot then. Right now all we have is a background and the Spacevan. The Spacevan is lovely, but wouldn't it be nice to have some other stuff on screen? We're going to create just a node. We're going to call this a spawner so that we can keep track of it. We're going to give it a sprite, and we're just going to assign basic Godot icon sprite for that. Now we can move this off screen here, and we're going to use this to send items towards our Spacevan. So we should probably set that at the same high value as our lanes. Okay. So we'll have 3 of them eventually. We're just going to worry about the one for now. Stretch real quick. Oh, that took longer than I thought because we ran into some hiccups there. It was getting the Twitch stuff working. I knew it would work because I'd tested it out in the past, but I'd forgotten just how much of a hassle it can be to integrate. Alright, so we want things to spawn out of our spawner. And so we are going to create a template or a package, a blueprint, if you will, a prefab if you're coming from Unity, called spawnables. Spawnables could be a great many sort of things. It could be coins, it could be asteroids, it could be lemons, it could be all sorts of stuff. Let's start building our template here. We're going to create Area 2D. Making Area 2D because an Area 2D can detect stuff, essentially. And we need our spawnables to be able to detect when they run into stuff like the player or other spawnables, or a lemon. That's right, PK. So we'll call this spawnable. No, we're not even going to call it spawnable. Spawnable is going to be the class name. Don't need to muddy anything. But an Area 2D needs a collision object. So we are going to add on a collision shape. We're also going to add a sprite. And then we're not going to define any of that right now. We're actually just going to save that as its own scene, which we're going to save in packages. We're going to call this spawnable. Just our base spawnable. We're going to delete that. Now we're going to open it up from our packages. It's a whole other scene. So this took me a minute to wrap around. So our instantiable objects in Godot are not resources like you would think of them in Unity. They're actually their own scene, act scene. We are going to duplicate our template here, and we are going to call it coin. We're going to duplicate it again. We're going to call this one asteroid. Let's start editing this. So for our coin, we've got a little cadet credits sprite here. So now we're going to define the collision shape. There. And that's good. Now we're going to open up our asteroid. do the same thing here. Assign it sprite. Assign it a collision shape. Circle the bounds inside a bit. It's a little leeway. Yeah, something. It's good. And there we go. We've got 2 spawnables. I initially thought, like, should we make our spawnables, like, should we define them via an interface, like in code? But I think just having a single spawnable script should be enough, because all of our spawnable packages will inherit that. Alright, so we need a script for our spawner. Attach a script called spawner. Script file, thank you. Also going to need to create a script for our spawnable. So I should actually assign this before I started messing around with the template. Oh, that's fine. Just copy it in. Okay, so what does a spawnable need? Spawnable needs a direction. It's going to have to be public so that it can inherit this from the spawner that it gets spawned out of. It's also going to need a speed. Okay, and then every physics process we're going to have to change the position of it. This dot position plus equals, and this one we can just do simple stuff like plus equals. Direction times speed times delta, yeah. Cast, of course, as a float. Okay, so now whenever our spawnable object gets spawned into the scene tree, it'll inherit direction and speed from the spawner. We're going to have to set that up, but that's going to be the function. And then it'll move in that direction until it encounters something. We should also set up on collision. You know what? Area entered. Where we are detecting a area 2D area. We're going to use this to collect garbage from the scene. Also need another method that we can call whenever we collide with a rigid body. Like, in our case, the player, or the Spacevan. Alright, but we'll get back to that in a second. Go to our spawner. What does a spawner need? A spawner needs a direction that it's going to be firing stuff off in. Set the base value of that to be left. firing to the left of the screen. We're also going to want this to be an exported parameter so we can edit it in the inspector. Similarly, speed, set it some 100. Now, when do we instantiate? We need to have a counter. For the counter to work, we also need export a frequency. So how many times per second are we shooting something out of the emitter? Try and dodge by the Spacevan. And I think it's better if we think about it as once every X seconds. We set our frequency to 2. When we instantiate the spawner, say that this dot counter equal to our frequency. Create a method tick every time that this script gets processed. We're going to feed in the time since the last frame that was processed, or the last physics frame in our case. We're going to say this dot counter equal to this dot counter minus delta. Yes, time since the last frame. Then, if this dot counter is less than 0, yep, good autofill. We're going to reset the counter minus any overflow. We're going to reset it to frequency. Minus whatever remaining counter there is. Then we are going to instantiate our spawnable. Now, in order to do that, we need to know what to spawn. So, we are going to, first thing that we export, or the first parameter that we take, it's going to be, let's see, spawnable array. And yeah, we'll call it spawnables. So if we go into Godot here, go to our main scene, just build here, we should see spawnable takes an array, it takes a direction, it takes a speed, it takes a frequency, and we can actually fill this up with spawnables, but we don't want it to be spawnable. We want it to be packed scenes. Right. That's right, Spaceman. The packed scenes are actually what we're instantiating. can't instantiate a spawnable on its own, because a spawnable is just a node that gets connected to something else. Think, Spaceman, think. Okay, so let's instantiate a spawnable. We need a random number generator. We want to randomly pull from the array spawnables that we have. And I think it's probably easier, instead of filling up this tick method, we'll just create a new method called spawn. Call that here. That's just easier for us in legibility. All right, so when we spawn, we're gonna make a random number generator. Then say packed scene spawnable equal to our spawnables array. Need an index number. This is where a random number comes in. So random number generator. Call Randy range. We need a random integer somewhere between 0 and length of spawnable array -1 of arrays. The first one, 0. If we have a length of 1, it means technically the index is 0. Everybody knows that. And then we are going to instantiate it. Cannot convert type Godot node to Godot packed scene. We have to cast it a packed scene, or as a node. What am I thinking? Yes. All right, so we get our spawnable. You can just say spawnable.instantiate. But we want to add this to the tree. So this is the spawner. We want to say this.addChild be instantiated spawnable. There we go. All right, that should work. Now, when we spawn, we need to assign some values. To give it direction, and we need to give it speed. Say spawnable direction. What do you mean I can't? Oh, because we have to cast it as a spawnable. Oh, direction, excuse me. Our public. That's the problem. spawnables in packed scene array, right? Cannot convert type packed scene to spawnable because wow. We cast it to an area 2D. Shucks, I've sorted this out before. I know there's some goofy casting that has to be done. Let me take a drink. All right. Even though that's what inherits. A2D also inherits from node 2D. What are you doing, Spaceman? Maybe I've been doing this wrong. We just cast them as Godot, I wonder? Or resources? This won't. I'm gonna do a little test here. I know it's not gonna work. Do a spawnable script. It's area okay. It's the asteroid. Now we're technically using the same script there. Spawner. Drag coin. It won't take it. It's supposed to be loud. Area 2D. Because spawnables inherit from area 2D. Is that what you're telling me? What you're telling me? Take area 2Ds or do we cast at? Find out. Project, what did I do? Don't worry about it. Don't worry about it. Can't do that. We're on to something. Act scene to what? Creativity on here. We have to get the shot node. I never thought this would be hung up on, because I'm sure I've done this before. Let me see here. Let's consult some documentation, shall we? Always fun. Meanwhile, I hope everybody is having themselves a lovely evening, and whatever you're working on, I hope it's going better than what we're working on. Alright, back to God. Why is this working now? Let's see. Because we instantiated it at the same time. That was the only difference. How bizarre is that? Well, I'm certainly typing words onto this document. You're doing your best, and that's what we'd like to hear. Okay, that's that. That was silly. Now we should be able to, yep, now we can call the direction. Or assign the direction to this dot direction. Assigning parameters, direction, and speed. That's all. That's. Then we could say add child spawnable. Now, can we make spawnables nullable? No. Valid on this declaration type. It is property index amateur. Oh, I see. Okay. We'll put that in. Spawnable can be null. Why is that, Spaceman? Because we cannot assign it beforehand. This is just for safety's sake. If I screw up something. So if spawnable. And that allows us the opportunity to basically leave blanks in the array. All right, now let's try this out. This should work here. We're gonna assign, oops, rebuild. Assign coin. Didn't want to load. Assign asteroid. Load for some reason. Let's see if this works in practice. Let's see. Question is, are we going to see anything coming off the side of the screen here? No, in fact, we're getting a lot of errors here. Object not set to an instance of an object. Okay. Stop. Let's try that again. Clearly, we've messed something up there, and it might have been me trying to give the allowance. Me trying to be too safe. Let's add a coin. Attempted to set an object of type pack scene into a typed array which does not inherit from area 2D. Oh, now it wants to work. Okay, I just had to reset the spawnables because it was still thinking we were inheriting from Area 2Ds. Alright, well that's dumb. Every now and then you run into problems. Alright, look at that. We can load a coin, we can load an asteroid in there. Now when we run it, you should see every 2 seconds. Whoa! That's way more than every 2 seconds. That's making a lot of asteroids. But why? Why? Close the game and find out. Oh, and look, there's a little coin in there too. Every now and then we get some coin. More like every 2 milliseconds? Yeah, exactly. Alright. The reason for that, I'm sure we've done something dumb here. Alright, this dot counter minus delta. Oh, shoot. It's right here. Look, it's right here. Can we blow that up? Look. This dot counter equals frequency equals this dot counter. No, that should be equals frequency minus this dot counter. Spaceman, you done goofed. One little misplaced operator like that, and it goes nutty. Alright, now this should work. Check it out. Every 2 seconds we should get bam, coin. Bam, coin, bam, asteroid, bam, coin. And, reminder, we can still move up and down locally, and you guys should still be able to control that on your end as well. But, nothing happens when we run into this stuff. Which is a shame. Because we haven't told it to do anything yet. So we're going to set that up now. Kind of already laid the groundwork for that when we were making the spawnable class. Now, we're going to think about making a score system. First of all, the Spacevan. it's going to have a public integer value called coins. Give it a little method. On collision. We're going to pass through an ID so we know what happened. Yeah. ID equals coin. And this dot coins plus plus goes up by 1. If the ID is equal to asteroid, and think of something else. Add that in later. When we get hit by an asteroid, we will lose coins. Maybe jitter. Maybe asteroid. Well, fill this in later. Keep an idea of what we want to have. Now for that to work, we need to go back to our spawnables. We need to give this a ID. String value. Now we could store this kind of information in like a JSON file, because Godot is pretty good at reading that, but because I think we're only going to need one value, I think we're fine. We're going to have to manually set that, which is why I make these in sort of like prefab. We can set the ID of the asteroid as asteroid. Save it. Set coin as coin. Save it. Now we already have area entered and body entered. Conditional method for our spawnable. First thing we're going to do, let's give ourselves the ability to delete errant spawnables. So once they get off screen and out of the way, we want them to be gone. Here's what we're going to do. We're going to actually set this up in the scene. Create a area to be. I call this garbage collect. Going to add number of collision shapes. These are just going to be really simple lines. Anytime something crosses this barrier, it'll get deleted. That's what we're aiming for. Let's go ahead. Select here. What's 512 plus 60? 576. Except let's play here. Actually, if we put it there, we actually need it to extend way out like. How far is that? Oh, that. Fine. We don't want it to come down here. If we came through like before the emitter could get to it, then they would actually start disappearing before they even get on screen. It's not something that... Okay, we're gonna make some more. So it's 256. 60. So it's 320, of course it is. Wrong. Cross. Plus 64 through 84. There we go. That connects. And it is possible that we're going to have stuff like exploding and coming off this way, so we're going to make another one that caps off the backside. Six, 4, 7, 6. Completely enclosed our play space here. Our garbage collector, we are going to add this to a group. Call it destroy. Now, we are going to go to our spawnable class. We are going to say, when we enter an area 2D, if area is in group destroy, gave it that label in the editor, and we're going to queue free, which is the shorthand for destroy this object at the earliest convenience. Thank you, PK, for that little hydrate. Gotta keep the brain working. Alright, now in order to get this function, we can't just say, hey, on area enter, and the game will, you know, assume it knows what to do. We actually have to connect. Much like we connected the Twitch calls earlier, but we can actually do this in Twitter. Go to our spawnable. We should have set this up beforehand, huh? Okay, going to the base class, spawnable. Say, hey, signals. So these are all the built-in signals that we can use. Area entered, we're going to connect area enter to our on enter. reads that automatically, so we connect. View. Now we can see we got this little icon here. We can do the same thing with the body enter. Let's see. View. But if we are to go to our coin or our asteroid, we're going to see those signals are not automatically attached. And we should have set this up on the spawnable before we on these two. Good. I think it's probably easier and faster. Remake them. Just going to duplicate. This one we're going to coin. And now we can see it comes pre-attached with the scripts, which is wanted. Not like this is why I don't love the packed scene way of doing things. I think this worked better in the prefabs. All right, but we're gonna add a sprite. Add our collision shape. Make a circle. Bigger. Should be. You know what? That's fine. And then we're going to give it an ID of coin. And that's it. Bam. Done. Coin. Duplicate another one. This one, asteroid. Asteroid. Oh. Collision shape. Good. Save that. That. Okay. Just need to set these. As well. Now we can go back to our script. This will work. Now let's do the on-body one. I'm going to say if the body that we're connecting with. This will detect stuff like rigid bodies, it'll detect character bodies, it'll detect anything kinematic. We're going to say if body.is in group, make an called player. We're going to call body.collision. Spaceman. How come? All right. I guess we gotta make a object perfect. Can't you? Cast. Okay. We're gonna say Spacevan player is equal to body casted Spacevan. Then we can say this.id. So just to demonstrate that everything works the way that we want it, when a collision happens, we can say dd.print, so this will print to the console. Spaceman collided with that's ID. Run it. Let's see what happens. asteroid thing is coming through here, so clearly it's not working the way that we wanted it to. What's that? Our looks like our stuff is being deleted, caught and deleted, which is good. By our garbage collector. Just gonna double check. Oh, you know why it's not working? Because we didn't make the player group. Duh, Spaceman, dummy. Okay, so Spacevan is part group called player. Now let's run it. Spaceman collided with asteroid. Spacevan collided with asteroid. Spacevan collided with asteroid. Spacevan collided with coin. Spacevan collided with asteroid. Coin. Okay, so we are reading that properly. That's good. And we've also seen that our garbage is getting collected once it's off screen. That's good. That's perfect. Now we need a reason to dodge this stuff. Let's see. We've got the basic functionality down. Now we're having fun with it. So we need some sort of like scoreboard or something. Let's make that in the editor. Gonna make a container. In that container, we are going to put some labels. Hello. Position and size determined only by their parent. That's annoying. Okay. Well, in that case, let's not worry about containers right now because we're not trying to make something for multiple devices. Let's just make control. Labels. This one, score. Here. Other one. Zero. Copy forms. Probably. What is that? Over. Let's see. Is it? Swell. Call this control. And I guess it's going to need a script as well. it's going to have to connect to our game manager. We're probably going to store more information in Game Manager. Going to be cases where we score. Label. Current score. Update the score. This current score. Text label. It's going to equal Game Manager player Spacevan, Spacevan .point. Set that. Dot string because it will be converted to string. No. Say that when we complied with scoreboard, so the game manager needs to have a scoreboard. Instantiate that at runtime. Just like player, or if we really wanted to, we could drag and drop them all together in inspector. But this works just fine. It also ensures that we only ever have one of each type at a time. Scoreboard, we're going to update score. Now, anytime that we act coin, our score should go automatically. Let's see if that works. Applied coin, and we've got errors in our debugger here. What's the matter? Object reference not sent to because we didn't assign the label. We have to do that. Of course. We're always forgetting something. Okay, so scoreboard. Remember what's score. Drop that there. Really. Should our scoreboard update score at runtime. Question is that safe? Not really, because we could call that before the Spacevan sort of makes itself part of the game manager. Sometimes this stuff is like based alphabetically, so because scoreboard gets loaded before Spacevan, If that is how it works. We're gonna see. We're gonna see if this throws an error. No error that I can see. Alright. We're gonna hit that coin and bam! Score goes up by 1. Score goes up by another 1. Nothing happens when we hit an asteroid yet. Score goes up again. Now we've got a reason to hit coins. It's good. Now, when we collide with coins, those should disappear. We don't need them to pass by the spaceman. And if we were really enterprising, we'd have them like go out with a flourish. A little ding or something like that. We don't have any sound effects to make the game. Let's see. Could just free it up after collision. Because anything that collides with the Spacevan, we're going to want to disappear. I guess we could let the Spacevan handle stuff like debris, like if we collide with an asteroid. But right now, everything that hits the Spacevan will disappear when it does so. Psh. Bing! Ping! Psh. But when we hit asteroids, I'd love for them to like explode into smaller asteroids. That's why we have these little asteroid small sprites. So let's set that up, huh? You know what? Instead of passing where do we want a decision? We could make a spawnable method called explode. Because who knows, we might want more stuff to explode. Different types of spawnables. Would have to... Yeah, it's gonna have to be in the spawn. I have to say... We're gonna have to store a vaccine debris. Allow that to be in. Should work because it's only one reference. Let's see if this stuff 3 is not equal. No, that's right. We'll just make something random. Say this to tell us pieces of debris to spawn. And we'll say we'll assign a random direction. Need a random generator. Here. Four. By 0 less than num plus, so we're just counting up here. We are going to spawn a new instance of our debris. Say technically a spawn? Technically it would be a spawn. Spawnable debris equal to this dot debris. Instantiate. Pass that as spawnable. And we're gonna say debris dot direction equal to vector 2 dot angle. A random angle, say, from our random generator. Range 0 to 360. Casting there, no, it'll take that even though it's not afloat, it's fine. Speed equals this dot speed. Inherit the speed and it's shooting off in some random direction. Okay. So now, instead of passing through the ID, and we're actually going to pass through spawn. So instead of this dot ID on collision, pass through this. Now instead of reading just ID, we need to spawnable dot ID. Passing a little more information. That allows us to say, if it's an asteroid, call spawnable dot explode. We can determine the amount of asteroid debris bits that we want. Let's say 3. So now, fingers crossed, let's go back to the engine. When we collide with a asteroid, it should break into pieces. Wait a minute. Won't work. We didn't add it to the scene tree. Say this done. Add sibling, because otherwise when we delete it, all of its children nodes will get deleted as well. Add sibling. We're actually going to move the collision from down here the end of the explosion. create debris, then it's going to delete itself. In order to not conflict with our coin, it's going to create another method, destroy. Which just deletes itself. We gotta go back to Spacevan, we gotta say, okay, coin, update the score, and we're going to dot destroy. Whereas the asteroid is on dot explode. And we can make a switch case for all sorts of different spawnable collisions. But this should work for us for right now. Alright, this should work. On the site to see. Okay, so right off the bat, we're going to hit an asteroid and... Oh! Didn't work. Didn't work. Why didn't it work? Collided with... Alright, so we're not reading data for some reason. Why is that? Bumble.id. Oh, hold on. First of all, I know why the asteroid wasn't exploding. We didn't actually assign any debris field. And because we were changing the base script, these fields changed as well. Oh, because I changed the name as I was around with stuff. Okay. So coin, we changed to coin. Debris is empty. That's fine. That. Asteroid. Change. Back. Asteroid. 3, we have to actually make a new spawner. Wait. Duplicate. Asteroid underscore debris. Up. Okay. Sprite's gonna be a small asteroid. Collision shape, which we will need, even though these won't do damage to the player. We do need this collision shape so that it can be destroyed once it hits the bounds of those garbage collectors. Okay, that should be it. Just gonna drop the debris in the debris field for the asteroid. Now it should work. Let's see. Let's hit an asteroid. Bam. Okay. Collided. Oh, hold on. I'm seeing stuff come out from over here, like where the emitter is at. Why is that? Why is that? Why is that? Adding it as a child. We need to set its position. Let's see. We explode. So what were those aims? Let's see. Booger. Can't change the state while flushing queries. Use call deferred. Set. What don't you like us calling? Space. Explode. You don't want us to explode. You free, or is it just the destroy the explode itself? What do you not like being called? Seems like it's working. Just have to change the location. sibling. Say 3 position equal this dot position, so it explodes out from where we are. Get a coin, score goes up. Hit an asteroid, explodes. Whoosh, yes, okay, so that's working as intended now. Except, game is pitching a fit. It doesn't like that we're calling it a specific order. I would also love to add some rotation to asteroids through the air or through space. We could add a rotation parameter to our spawnable. Can't change state with flushing queries. Use call deferred. Used call deferred before, but what are we for here? The add sibling? Let's see here. For string name method. That can it explode? Oops. Called bird. Say spawnable dot bird explode. Say parameter of Does that make you happier, Godot? Even though you're doing exactly what I wanted you to do anyways? That was it, apparently. Okay. Not having a connection anymore. That's good. It goes psh. However, we should like for us to lose coins or reset our score or something when we get hit by an asteroid. So as to give us some incentive to avoid, right? We want to be like this. And then we want to be like that. Wow. Get out of there. And of course we'll have other stuff coming from other lanes. Probably make the ship fly a little smoother. Maybe we can... No, let's just drive straight into the rocks. Straight into the rocks! Straight ahead! Hold on. Let's go... Cool. Main. Background. Where is the... Oh, it's under the shader. So here, where is the material? Come on. I was gonna say, can we invent like a hyperspeed? That would be a good name. Hold on, let's see. Background. Right, speed. Let's go something like 1. And then set our spawner frequency to 12. And speed be 500. Let's hit it. Let's go, PK. Oh, wait, hold on. Change the frequency? Right, we want that actually like 0.2. There we go. Yeah, no, I had that backwards. Here we go. Ludicrous speed. We're heading for the high score, bud. Let's do this. Rocks on rocks on rocks. Yeah, boy. We're just plowing through space. Yeah, actually being able to control the speed would be a fun thing to do. Especially when we start adding like pickups like force fields or missiles and stuff like that. Then we go, pew, out of the way, and then break back into it. Safety? Yes. Who needs seatbelts, am I right? I really want to keep working on this tonight, but we're already like 3 hours in. Let's do one more thing. Look at our score, man. That's big. That's big numbers. Let's do one more thing tonight. Reset. There we go. Back to how it were. Back to how it was. I was thinking maybe we could do like a little sonic effect or something when we get hit by an asteroid where we lose all our coins. We could make like a little ring around. Let's see. We do. Maybe. That'd have to be a method in Spacevan. Yeah, because we want it to explode out from the Spacevan. So, here's what we're going to do. Are spawnable. Should be, they should have value. Act. Allow us to create one. Can't be interacted with. There, that's all. Do. Let's see. Set the base value to be true. Load it there. Say, play void. Eject points. Dot coins greater than 0. Check there. There we go. For the explosion. Look at that. Getting there. Already blown up the asteroid. I want to add like jitter effect, which maybe we'll get to next time. Maybe we'll keep doing these streams like the rest of the week or something. Ah, but no, you know what? I gotta work on the Valentine's Day skin. So if this dot coins is greater than 0, we need a... Yeah, we'll need a random number generator for this. Might want to hold it. Quote. Angle. Let's see. We need an angle that's divided by 360. Equal 360 degrees divided by the coins. I don't have to put this dot coins, but I always put this dot whatever for local variable. Let's see, or with this room. It's not necessary. It helps me read it. So coin angles equal to 360 divided by coins. Plus, we're going to put it on that 4 I coins plus good. What are we going to do? Spawn coin. Say spawnable coin. 2 stud coin. Is that what we called it? That's not convention. Checked. That's not a good naming convention either, because that's it's close to the name of our method. Dead coin. It's instantiate it. Coin. It is false, so that I'm going to collide us and thing as soon as I did. Say coin dot direction equal to coin angle or 2 dot from angle. Angle is going to be coin angle time 1 plus I, the 0 value. Or you know what? Yeah, we can start at 0. That's fine. Coin angle. So we can just say coin angle I plus a random value. Guess we need that too. Yeah, so handy range 0 to 360. You know, from 0 to 180. We need to do a full rotation. The direction, coin.speed equal to x.speed. Well, we don't have a speed actually, so we'll just make a parameter called check speed. Set it basic value 2. Okay. So it will still collide with our garbage collector. Just need to add it to the scene. We're gonna say but this dot and sibling point. Go. Should work, should work. Let's see it in practice. You know what? This is actually just gonna add up and get bigger and bigger because we didn't set the asteroids to reset our score. So we hit 1. Up. Problem because we didn't set the Spaceman's dead coin value. Let's put coin prefab in there. Go. Now busting into things. So we've got a score of 1. Putting So again, when we're adding, we're gonna see it up here. Okay. We need to change its position. Position equals this dot. Position. Yeah, because we're not adding it as a child. If it was adding it as a child, it would be fine to keep it. It would inherit our. So we're not. Alright, here it comes. Asteroid. Bam! Look at that. Now 4. Bam! So hold on, it's actually shooting them out in a random direction, more so than I wanted. I was thinking it would be more uniform, like a circle around Spacevan. Also, some error. It's a problem. Change state, well, queries again. Add sibling. That what was causing us problems before? Small file? I thought we had. See. For oh my goodness gracious. Historia Gaming, how are you doing? And how are all your friends? Thanks for tuning in. We're doing a little Godot stream tonight. Very cool. Check this out. We're making a little game that you can control. Floppa Raid, thank you so much. Hello, Raiders. This is the Vector Spaceman Show. I'm, of course, your host, Vector Spaceman. We're getting ready to wrap up for the night, but let me show you what we've been working on. So we've been working on a little mini game that we can run in chat, which is very cool. Oh, just a little side scroller, sort of endless scroller, collect and dodge sort of thing. Look at this. We want to dodge asteroids because they blow up when we hit them. We want to collect coins when we run into them because they make our score go up, which is great. We haven't put in resetting scores at the moment, so we don't have a real reason to avoid the asteroids, but it's very cool. You can see in the chat, in the redeems here, we've got to move up and move down redeem. It actually controls. Oh, hold on. make sure that we actually have a connection to Twitch here. There we go. Actually controls our position on the screen. There we go. See, move down, move up. Everybody can control that. That's very cool. And we're going to be continuing to develop little mini games like this. That's what I'm working on tonight. What were you guys doing? Let's go ahead and give a big shout out to Historia Gaming. Friend of the show. Make sure you check him out. And PK loves hitting asteroids. It's just the best thing. Okay, but we cannot defer our call for adding a sibling to the scene tree, is what we found out. So we have to find some other way to eject these coins. Played a few games, played some Elite, Carrier Command, DCS World. Nice. Solid choices. I haven't been into Elite, or Elite Dangerous, rather, the knockoff, the successor. Some time now. I have to dive back in. Streaming for 6 hours, man, that's way more than I could ever do. We've just passed like 3 hours here. It's about time for me to log off, I think. I'm gonna try to make one more change. Let's see. What? Calling eject. It's because it's in the on collision. That's why. All right. Here's what we're gonna do. Very cool. Called it for eject coins. I can spell deferred. Okay. Now that shouldn't give us any more problem. Shooting harms, shooting down planes, that kind of thing. Okay, no errors there. We're hitting rocks. We're gonna pick up a coin, pick up a couple of coins. And next time that we hit an asteroid, they should explode out from within us. Bing, look at that. That's great. And because we didn't reset the score, it's just gonna keep doing that. It's gonna keep doing that the more and more coins that we get. So, just to make PK and others happy, why don't we end the evening like this? Let's see, our spawner changes to 1. Change the speed to 500. Go back here. There we go. Look at that. What a mess. That's what we like to see. That's Gamedev right there. Oh yeah, look at that. Ain't that satisfying? That's like some, what is it? Like the vampire, survivor type stuff. Oh, it's starting to slow down the screen. It's like a firework. All right, we gotta shut that off. What are the limits to the amount of spawnables we can have on screen at any given time? I wonder. The score's not reset? Yeah, no, that's pretty simple to do. We just hadn't implemented it. We would just say on collision. If it's an asteroid, then this.coins. Equals 0. See? Pretty easy. Although, we actually wouldn't put it right there, because then that would interfere with our eject coins call, so we would make sure that happens after we eject coins. And then we would say this game manager scoreboard update score. So yeah, now if we were to run it again, it would function more as intended and actually give us a reason to dodge stuff. Like, look at this. Pick up a coin, we lose a coin. Pick up 1 coin, 2 coin, 3 coin, 4 coin, and you know what? I'm gonna pause it right here. There's a reason that that didn't, I'm very sorry that that didn't fire for you. Yeah, we had a connection error there. Let me make sure that it actually connects. Okay, we are connected to Twitch. Now you should be able to move up and down. Oh, hurry up, guys. Oh, there goes our score. Oh, okay. We're out of harm's way, but we got no coins. We're gonna have to sneak back up in there and pick some up. Can we be quick enough to dodge the asteroid? We gotta kind of get used to the lag between wherever you guys are and, oh, here looks like a good opportunity. There we go, there we go. Oh, can we get out of the way in time? Ah, there goes our score. So yeah, that's the basic premise. It looks like... Here, I can manually control it as well from my end. If we dip down, dip back up, try to get like 2 or 3. I know, they're not exploding anymore, and I think I know the reason for that. Because, let's see. We're saying call deferred for our eject coins, and then we're immediately changing the amount of coins. So instead, we're going to put that into the eject coin method so that it doesn't get done until the stuff actually gets ejected. Right here, we're going to say this.coins equal 0, and then this.gamemanager.scoreboard update. And now it'll work. Okay, you guys have got the con. No worries, because right now we got no score. Here we go. Bing, there it goes. There goes our single coin. Now if we collect 2, or maybe 3, here, I'll help out. Go. Sorry, PK, I stole your thunder. There we go, there we go. Alright, now we got 3, let's see 3 explode. Bam, just like that. Let's see 1 explode. Bam, just like that. So now it's working as intended. And next time we do this, we'll probably implement a high score that we can track between gameplay sessions. We'll probably add some more stuff in the background. We'll add multiple lanes of stuff to avoid, and we'll probably get to use some of the other sprites that we had set up here, like the power-up magnet, the power-up missile, or the power-up bubble shield. Get to implement some more stuff, have some more fun with it. But I think that's where we're going to call it for tonight, you guys. So, set up here. Let's head back to the main screen. Thanks for tuning in, everybody who's usually here, and thanks, of course, to the Raiders. Did someone say bubbles? Yes, bubbles. Maybe even some lemons, PK. Let me check on over our twitch.tv. Maybe we can go say hi to some friends. Some friends. Doing game dev here. Let's see. Not quite. But we could go say hi to some fellow game developers. You go say hi to Meg and Don of the game Grotto. I got affiliate since the last time you saw me. Nice, nice. Have a great night. Thanks for showing up, PK. Thanks for tuning in. Thanks to everybody. I think we're going to go say hi to the game Grotto, Meg and Don. Let me set up that raid. Remember to be pleasant, to be nice, say nice things. You're stellar representatives of Harbor Station. I know you are. We're going to say hi to Meg and Don, who are independent game developers themselves, and looks like they're some cheaper robo tonight. That's cool. Alright. I'm going to get that going. Looks like we're all set up, ready to rock. As always, I want to thank each and every one of you for tuning in tonight, wherever and whenever you are. You can join us again next week, same time, same place, right here at Harbor Station. If we're not around even sooner, because I'm going to want to keep working on these mini-games. It's been a fun time. Until then, of course, no matter what life throws your way, good luck and Godspeed. This is Vector Spaceman signing off. Thanks for tuning in, everybody, and stick around for that raid, because we're about to send you off for some more great content for your evening. Take care, everybody. We'll see you again real soon. Bye-bye.